Hello folks and welcome to Some Codex. In this episode 13a, I'm gonna be talking about MIDI. I decided to start this video with a very brief introduction on what MIDI is and a little bit of history. Nothing boring, promised. MIDI stands for Musical Instrument Digital Interface, and it's a communication protocol, a communication system that was developed to encode musical gestures, musical events. So let's say that I press a key on the keyboard on a synthesizer. If this synthesizer is using MIDI protocol, it will define the pitch of the note being pressed, the intensity of the keystroke, so it will use the velocity parameter. It will define if the note is pressed or not, so it will use note on and note off parameters. All these parameters can be packed within a message that is sent through a MIDI channel. The MIDI protocol uses up to 16 channels and parameter values ranges from 0 to 127. Of course, these four are the essentials you can use to properly encode a musical note, a musical gesture. Back in the days when MIDI was invented, it could encode pitch, velocity, and modulation only. Now, with the general MIDI, which is an improved and standardized version of the old MIDI protocol, we can encode way more parameters. General MIDI is sometimes named GM or GM1. And when I'm talking about extra parameters that we can encode, I'm referring to program changes. So we can change the instrument voice with a MIDI message, and control change, which is a set of parameters that can be used to change overall volume, stereo balance, expression, and many other settings. This picture was taken in 1983 at the NAMM, the Winter NAMM, where for the first time ever they connected two synthesizers from different companies. Yeah, because years ago it was not easy at all to connect two instruments from different companies, from different brands. Here we can see this Roland Jupiter 6 connected to a Prophet 600. And 1 year later, Roland developed its first MIDI processing unit that looks pretty much identical to modern ones, those ones that you can buy in any music store. That's more than enough about history. Let's take a look at how to use MIDI in Plugdata. The first object I want to show you, it's called a keyboard, and it's a super handy tool that is part of the else library. From the inspector, you can change the start octave and the number of octaves. We can limit this to 2, and we can start from C4. Great. Now, this object works in two modes, the toggle mode or the normal mode. In toggle mode, if you press a key, it will keep that state as long as you repress the key. I don't like this behavior, so let's switch to normal mode. If we add a list object box, we can see what does this object output. So if I press this C4, we can see that it outputs two values. The first one is pitch, the second one is velocity. So 60 is the MIDI number associated to C4, so middle C. And here we can notice that velocity changes. And with this object, velocity, it's relative to the position on the y-axis. So if I press the key here on top, it will have a very low velocity. If I press the key down here at the bottom, it will have a higher velocity. Funny little story. Back in May 2023, I was still using PD Vanilla, and I didn't know about the else library, and I needed a virtual keyboard like this one to play with mouse click. And I came up with this abstraction that uses a pretty strange workaround to make these canvases playable with mouse click. And maybe here I'm showing that there are bangs underneath these canvases. This abstraction, it's totally useless right now. And I mean, it was useless 2 years ago also. And yeah, that's it. End of the story. Sometimes we waste a lot of time making useless things. And that's it. Let's see how to use these values to make sound. So the first thing I want to do is to use unpack to split these two values. Since they are numerical values, I'm going to use float. And here now I have two independent values. Okay. Now I want to output an envelope only when velocity is greater than 0. So here, what I can do is I can use this relational operator, greater than, and I'm asking, is that value, the value I'm receiving, greater than 0? If so, this will output 1, if not 0. Let's take a look. Greater, not greater. Then I want to pick this pitch and turn it to frequency with MIDI to frequency, M to F. And then I can use this oscillator to produce sound. And I want ASR, attack, sustain, release, to draw the envelope. And if I'm not getting wrong, I need to convert the gate to an audio signal. I can use sig. I then multiply my OSC by the envelope and I send it to the output module. Let's turn on the volume. Oh, and I need to set attack and decay time. So 20 milliseconds and 400 milliseconds. The next object we're going to use is makenote. This is a pretty useful object that can receive MIDI pitch, MIDI velocity, and note duration, and it will output pitch and velocity. So thanks to this object, I want to make a random chromatic note generator. We can use rand.i, and I want MIDI notes in the range 60 to 72. 60 is C4, 72 it's C5, so I'll cover an entire octave, and you can go to the first inlet, and then I need random velocities as well. So I want velocities from 50 to 120, and here note durations. Oops, I want from 50 to 500. Great. Now I can use a metro activated with the toggle. Then I can use a trigger bang, bang, bang. And I want to use the first outlet to trigger my last rand I, the one that sets the duration. Maybe we can use comments to make things more understandable. This is velocity, and this one is pitch. Okay, so this is setting a new note duration. Maybe let's increase the minimum value to 200, and then we can increase the maximum to 1 second. Great. And I also want to change the metro timing. So we can initialize this metro to 100 milliseconds or 500 milliseconds. But after the first bang it's sent, it will generate a random duration that is also sent here to change the metro timing. And you know what? I can also add a time offset of 10 milliseconds. In this way, thanks to this offset, I'm creating a delay between the end of every note and the beginning of the new one. Then velocity to trigger this random number generator, and pitch. And we should be good to go. Pitch and here velocity. I don't know why these labels are so small here. Anyway, we can copy this section. So MIDI to frequency, and our envelope. ASR is using a fixed attack and decay time. We can link this duration to the overall envelope duration. What I can do is I can take this output, this one, and subtract the attack time, which is 20 milliseconds, and this value can be my release time. So you can go here. Can we send a float also? Yeah, we can. Let's take a listen. We can turn on the volume. Yeah, maybe we can decrease the overall note duration from 100 to 300. And we can decrease also the attack time from 20 to 10 milliseconds. Let's hear this. This is more than enough to start sending notes to your DAW. And this is one of the most beautiful things you can do with Plugdata. The interaction with your DAW, it's just amazing. So it's super simple. You need to use note out, MIDI note output. It takes MIDI note, MIDI velocity, and MIDI channel. Now we can take a look at the help file. MIDI outputs, default channel 1. Okay, so we can leave it as it is. We can send our randomly generated pitch and our randomly generated velocity. Make sure to open Plugdata FX, which is the audio plugin version of Plugdata. Then we can create a new track. This is my destination. Here I can load Surge XT. One of my presets that is Juno 6T. Okay, then what I can do, I can send my MIDI to my destination track. I don't want to send audio. I just want to send all MIDI, this Plugdata track it's generating, to all destinations. Great. I think I'm good to go. And that's it. Super easy. In case you needed to send MIDI notes to a specific channel, the only argument note out takes is the MIDI channel. So here we can write channel 3, for example. Then we can move to our DAW routing and we can set our MIDI channel 3. Well, let's try with MIDI channel 4, which is wrong. So it should not work. Yeah, it is not working. We can change it to 3. Great. At this point, we know how to send MIDI notes. Let's see how to receive MIDI notes from our DAW. So let's get rid of note out because I want to use note in. It works in the exact same way. So you can set an argument, which is the input channel, and it outputs MIDI note number, MIDI velocity, and MIDI channel. Here I want my MIDI note. We can get rid of this to be sent to the MIDI to frequency. I want my MIDI velocity to go here. And if it is greater than 0, it will activate this envelope. And we can turn on our output. Then we can get rid of this section as well. We can delete our destination. Yeah. And we can write some MIDI notes here inside the Plugdata track, random notes. And let's hit play. Interesting rhythm, isn't it? This patch should work on all major DAWs. In case you need some specific routings within your DAW, make sure to read the documentation on the official Plugdata website. Under documentation, select DAW setup, and you can scroll here until you find your DAW. Here we have Ableton, Bitwig Studio, all major ones, Reaper. So far, we've been using velocity as a simple trigger to activate or deactivate our envelope generator. Effectively, we're not using velocity in the way it should be used, so to shape the dynamic range of a signal. So what we can do here is we can take the velocity and we can scale the range 0 to 127, which is our input range, to the range, the numerical range used by Plugdata to change amplitude, that is 0, 1. Now we can take velocity, we can make some space here, and we can convert this float to a signal. We can add an interpolation time to make this transition smoother. And finally, we can multiply our oscillator by this number, which effectively is an amplifier. Make sure to amplify and use this multiplication out of the oscillator output and not after the envelope. That would sound different. I think we're good to go. So let's take a listen. Here inside the piano roll, I manually changed velocity. So we have maximum velocity, low velocity, then something in between. Next up, we have MIDI. This object is part of the else library, and this is a pretty powerful object that you can use to read and write MIDI files. If we take a read here, we can see that it plays and records raw MIDI streams. And here we need to point out the difference between raw and cooked MIDI data. Now, if we take a look at MIDI.in, which is also part of the else library, it is used to get cooked MIDI data. And by inspecting its help file, we can see that it sends cooked MIDI data instead of raw data like MIDI.in. So let's take a look at MIDI.in with that dot. If we open the help file, this will bring us to this generic page where we can see all MIDI related objects. Here we can see the note in object that we used before, and we can see that it outputs cooked MIDI data. We can easily interpret its output. We can see the note, MIDI number for note, MIDI number for velocity, and channel. Different story for MIDI.in, that, as we can read down here, it handles raw MIDI byte by byte. Here we are on the computational side of computer music. We want to dive deeper into aspects related to raw MIDI, but it's worth mentioning this difference since the MIDI object uses and handles raw data. Just to recap, raw MIDI data deals with the information being carried by specific bytes within the MIDI message. It's difficult to read since the MIDI protocol uses binary structure, hexadecimal structure. So something that deals with computational aspects of computer music, we don't care about that much, or we don't care at all in this course. Cooked MIDI data refers to the raw data being interpreted and transformed in a more human-readable form, like the one used by note.in with MIDI note, MIDI velocity, and channel. So let's move to the help file of MIDI. We can start and stop playback with a simple toggle. We can send a message with any of these arguments, keywords, for example, start playing the sequence, to stop the sequence or recording, and many others. So I encourage you to read through the help file for a clear and detailed explanation. We can load a MIDI file in two ways. The first one, we can use the open message. This will open the computer window where we can search for the MIDI file. Or if you are in run mode, you can simply click on this object and the same window will pop up. I want to open this MIDI sequence that I prepared for you. Now, out of this outlet, we have raw MIDI data. Out of this one, we get a bang every time the sequence ends. So we can add a bang to visualize the end of the sequence. We can use a toggle to start playback. And I want to use a keyboard to visualize the notes being played. Since this object keyboard handles cooked MIDI data, we need to convert raw data into cooked ones with note.in. And I think we're good to go. Maybe we can set the loop mode with this flag that is a -loop. And it's not working. Let's reopen the MIDI sequence. Great. Now we can use some extra parameters like this message that is speed $1, and we can use a slider to change the playback speed that is in percentage to minimum 1. Maybe it's better not to use 0. Well, let's try with 0. Maximum 200%. We can use a message 100 to set playback speed to normal speed. Okay. Now, if I decrease playback speed, we can see that the sequence is slowing the pace. Let's see if it stops. Yes, it does. Now it's time to see how to write a MIDI file in Plugdata using the MIDI object. The solution I'm gonna show you is not that handy, since the easiest way is to send notes to your DAW and record from there your MIDI file. You have your built-in MIDI editor and you have the piano roll, so you can edit, make changes to your MIDI file within your DAW. So this method, it's useful only if you want to stay in Plugdata standalone application. I have no idea why you should do that, but anyway, this is the easiest way you can write a MIDI file within Plugdata standalone application. We need to set a few messages. The first is record. Then we need to stop recording. We need to save our recording and make sure to specify the name. Might be test01.mid. Make sure to write the file extension also. And we can send all these messages to the MIDI file. Now, what do I want to record? Well, we can reuse the chromatic random note generator we made earlier in this video, and we need to convert this makenote output to something usable by MIDI. So we can use note.out, which takes pitch values, velocity, and an optional channel, and sends out raw MIDI stream. Great, so pitch goes here, velocity goes there. We can send the note out to the MIDI in. And since I want to listen to what this makenote is producing, we can open the MIDI help file inside PD write. We have this sub patch. This is a basic synthesizer that we can use to listen to what it's producing. We can use note.in to convert the raw MIDI stream into pitch and note on message. Then we can use output tilde to listen to the synthesizer. Let's hit this toggle. We can press record. We can stop recording. We can stop the random note generator, and you simply need to hit save. This is the folder where I saved my patch, and here we can see the test01.mid. To play back this file, We can use the previous example and we can load test 01. Make sure that playback speed is set to 100%. We can link the PD synth. And here we have our random sequence. So the approach shown in this patch is, to my point of view, the most interesting one when it comes to MIDI recording, because here we can easily see the algorithm made to generate notes. Then we have makenote, which is our lifesaver since it makes things very easy. You have pitch, velocity, note duration. And then easy peasy, note out, MIDI. These two objects work together. And in case you want to monitor your output, which might be a good choice, note in and PD synth for a quick and easy solution within Plugdata, or you can use note out without dot in between. We already know how to use it. You can take the MIDI number and the MIDI velocity, and you can send your musical sequence to an external synthesizer, to a virtual synthesizer, maybe in your DAW, or anything that comes to your mind. This patch instead shows how to properly route the keyboard object to record some notes with the MIDI object. So routing here is identical. What we don't need anymore is the note.in object in between the keyboard and the PD synth. The reason is the output of a keyboard is a cooked MIDI message, note and velocity packed in one message, while note in takes raw MIDI and outputs pitch plus velocity. In case you're one of those extremely precise people and you've noticed that note in takes 2 inlets and has 2 outlets, let's talk a little bit about note in. So it takes the raw MIDI data here and the MIDI channel, which is an optional value. Fine. But how about the outlets? So the first one is MIDI pitch and note on velocity. The second one is MIDI pitch and note off velocity. So far, we've been using the note on velocity only. And the reason is that with modern MIDI, velocity is used to determine when a note stops playing. When velocity is 0, we assume that the note is not playing anymore. This behavior might change, especially if you're working with those sound modules that works with MIDI. There are some specific instruments that works with the note off message, but mostly we don't need it. We can use velocity to determine if a note is still playing. We can also end this video by taking a look at the difference between a cooked MIDI data and the raw one. So out of MIDI, we get raw MIDI data. Great. And I prepared for you this beautiful middle C. Let's take a listen. And here we have a list of raw data. We can start by talking about this value, 144. If you remember correctly, I said that MIDI works with values in the range 0 to 127. But here we're not talking about the final message, the one that we can interpret. This is the one we can easily interpret. This is the lower level of MIDI data. And the value 144 is associated to the note on message. More precisely, it is the status word that defines note on when the MIDI value, the MIDI note, is sent through channel 1. Moving on, we have the MIDI pitch and its velocity. Then we have a bunch of other numbers that we don't care about. At the end, we have MIDI pitch 60 and velocity 0. This is not a true note of message, but we say, hey, velocity is 0 here, so stop playing that C4. How about the cooked MIDI data? So we can write cooked and we can grab the output from note in. We can leave this for now and we can play the C4 note. Much easier and way more understandable. 60, 96, 60, 0. Easy. At this point, we can see how to use an external gear like this Swing Behringer USB keyboard to send MIDI notes to Plugdata standalone application. First thing we want to do is to enter the main menu, settings, under MIDI tab, make sure to activate your input device. In my example, Behringer Swing is enabled. We can simply use note in or note.in. The difference is that note in will output pitch and velocity as separate values, while note in will pack them for you. So there's no need to use, like I did here, the pack float object. And if I start playing some notes, we can see that the two lists are just identical. On the other hand, if you want to send MIDI notes from Plugdata to an external synthesizer, you have two options. You can either use your sound card if it has MIDI output, of course, or one of those USB to MIDI cables. They are super cheap, and you can see my USB MIDI cable that I connected. It's enabled. Now you don't see it, but it's flashing, so it's active. And you'll simply need to use a note out object. We already know how to use it. Make sure to use a make note to set the duration also of your note, pitch, velocity. If you want to change the MIDI channel, well, here you can write it as a new argument. That's enough for today, folks. Thank you so much for watching. Part 2 of this video is available on my Patreon page. Yeah, because there is a part 2 where I'll be talking about MIDI polyphony, voice allocation, voice stealing, legato, portamento, and a few other really interesting things about MIDI. It's working. It's making chords based on the C major scale. If you have any question or if you simply want to say hi, write a comment down below and I'll catch you in the next video. Ciao, ciao!